Okay, part two, what does the relativity bit mean? We always make relative comparisons every day. For example, my cup of tea is always hotter than some tap water, and some tap water is always warmer than a block of ice. Most people, if this was SWG, Mr. Watling, most people are significantly taller than Mr. Watling. Standing next to Mr. Watling makes average sized people feel tall. And if this one is going to be Mr. Cartilage, this is why everybody studying maths should study maths in the company of Mr. Cartilage. Anyway, the relativity that we will most be concerned with here is that of relative motion. So, if you are driving along a motorway at 50 miles an hour, so we'll have you and me are in this car, so this car has whoever you are and me, Mr. Jarrett, and we drive past Doc North, who can be sitting at roadside on a park bench and not moving at all. So if we pass Doc North at 50 miles an hour, and we'll all agree that all the objects are going to be pointing in this direction, then from Doc North's perspective, he sees us in the car travelling past him in a forwards direction with a velocity of 50 miles an hour. But from our frame of reference, when we look at Doc North, we see we're stationary and we see Doc North moving backwards with a velocity of 50 miles an hour. So if we add an extra layer of complexity to this, and that is that as we pass Doc North at 50 miles an hour, at that same moment, Mr. Watling, in his AC Cobra here, passes by Doc North at 70 miles an hour. So from Doc North's perspective, he sees us travelling at 50 miles an hour in this direction, and Mr. Watling travelling at 70 miles an hour in this direction. Mr. Watling sees Doc North travelling backwards at 70 miles an hour, and he sees us travelling backwards at 20 miles an hour. We see Doc North still moving backwards at 50 miles an hour, but we see Mr. Watling passing us travelling forwards at 20 miles an hour. So we can link those different perceptions of velocity from one to another using simple mathematical transformations. And we can adjust our frame of reference from this car to imagine what Doc North would be seeing, and also to imagine what Mr. Watling would be seeing as he passes in his fast car. So now let's do something Einstein would call a Gedanken experiment. So we can all imagine being in cars and actually do this experiment, but what we're going to try and do now is something Einstein would call a Gedanken experiment. That translates from German roughly into something known as a thought experiment. An experiment that is pretty much impossible to do practically, but can be imagined in the mind. So first of all, we're all going to imagine the same thing, and we're all going to imagine a very large white ice hockey rink. So white and so large that you cannot see the edges or get any sense of movement by looking at the floor. Now, put yourself in a box. So let me draw a box. And in the box there is a small letter hole through which you can peep. So here you are peeping through a letterbox. Now put yourself, as well as that letterbox, when you peep through the letterbox, you see another box opposite you, identical, with a letterbox as well, and someone else is in there looking back at you. Okay, now what you notice is that as you look out of your letterbox, so this one is you, and the other one is someone else. When you look out of your letterbox, you notice that the other box and person in it is getting smaller and smaller and smaller, possibly because they are moving away from you. Now, the problem with this thought experiment is that this is an impossible situation. From your observations, you would like to think that you're stationary and the other box is moving away from you at a constant velocity, but there's no way of telling that. It could be that they're stationary and you're moving away at a constant velocity. It's even worse, because you could both be moving with a velocity in the same direction, let's say here to the left, but your velocity is just slightly larger than the other boxes. So because there's no way of telling, we create a tricky situation here. So what we would also have no way of telling what common direction these velocities would be in. So it could be to the right, it could be to the left, it could be into the page, out of the page, or whatever. So, oh geez, this sounds complicated already, and all I've done so far is describe the two words that make up the title. Hopefully the application of maths later will calm things down a little.